Welcome to the Deep Dive. If you've ever felt like the list of global environmental problems is constantly growing and maybe adding species you've never even heard of, well, you're right. Today we're diving into a really crucial 2018 paper. It's led by Seebens and a huge team of collaborators published in PNAS, and it fundamentally changes how we think about the influx of non-native species. For you, the learner, this is kind of the shortcut to understanding a critical defining feature of the Anthropocene. You see, the entire apparatus of biosecurity, it relies heavily on knowing invasion history. If a species has been invasive somewhere before, we flag it, right? Simple enough. But what happens when a species has absolutely no invasion history? None at all.
Exactly. That is the core mystery this paper tackles. They call these emerging alien species EAS for short, and they are really the unknowns of invasion biology. These are species never recorded as alien anywhere else on the globe, yet they suddenly show up, they establish, and sometimes they become a new permanent fixture in an ecosystem. So our mission today is to understand why this emergence is still happening at such a high rate, despite centuries of global exchange. We're tracing the temporal trends, looking for the true origins, and figuring out the critical policy shift this research really demands.
Okay, let's start with the scope then, because to tackle a problem of this magnitude, they must have pulled from centuries of records, right? What exactly did the researchers look at to draw these big conclusions?
Oh, the scale is immense, truly. They synthesized a global database spanning over 500 years, think from 1500 right up to 2005. And they were looking at, 45,984 first regional records. That's of 16,019 established alien species. And it covers almost every major taxonomic group you can think of. Plants, mammals, birds, fishes, insects, mollusks, crustaceans, others too. They essentially created the global invasion timeline.
Wow, okay. What that timeline showed is, frankly, pretty shocking.
Well,
Because you'd expect, wouldn't you, that over 500 years of global trade, colonization, all that, we'd have kind of exhausted the low-hanging fruit, the species most likely to successfully invade. But what did the data show about the most recent years they studied, like the early 2000s?
Yeah, that expectation of depletion, the idea that the rate of new species showing up for the first time should slow down, it just didn't materialize. Even in the period between 2000 and 2005, fully one quarter, that's 25% of all new first records globally, were species that had never been recorded as alien anywhere before. They were truly emerging. So think about that. For every 4 new invasive problems we identified, one was a complete biological surprise.
That's alarming. It confirms the reservoir of potential invaders is far, far from empty. But drilling down into those numbers, there's an interesting skew, isn't there? The paper noted that most species are actually pretty bad invaders overall.
They are, yes. The vast majority, 58% of all species in their massive database, they only have a single first record, just one, which means most attempts at introduction probably fail, or maybe the species stays very localized and doesn't spread widely once it arrives in its new alien range.
Okay. So, if nearly 60% of alien species are localized failures, and only 25% are these emerging unknowns, doesn't that maybe suggest we're wasting time worrying about the emerging 25%, especially if they likely won't spread widely anyway? Why is their initial emergence still so critical?
That's a really excellent point of skepticism. And the reason their emergence is critical is basically twofold. First, you simply don't know which of those 25% emerging species will become the next superspreader. It's a gamble. Second, they found a tiny number of species, just 26 species in total, had 50 or more records each. That shows massive global distribution. Think of things like the longhorn crazy ant or the domestic pigeon, which clocked nearly 200 first records worldwide. We have to try and contain the unknowns before they join the ranks of those few really successful widespread invaders.
Right. That distinction between the many localized ones and the few global pests, plus this continuous flow of unknowns, that really sets the stage for the paper's most critical finding, I think. The conventional wisdom for centuries has basically been that invasions rise simply because the drivers increase. More trade, more human mobility. But this study found those factors alone couldn't explain this relentless emergence of brand new alien species.
That's exactly right. The models they built showed a stark contradiction. If the volume of global trade simply increased, well, it should just recirculate the same pool of potential invaders faster, which should actually lead to a quicker depletion of the species that can invade successfully from those known pools. But that's not what they saw in the data. The rate of emerging alien species, the EAS rate, it remains stubbornly high.
So something else must be going on.
Precisely. The only way their models could explain this continuous high emergence rate was if the fundamental source pool of potential invaders, the places they're coming from, the total number of candidates, was also increasing over time.
So it's not just how much stuff we're moving, it's where we're getting it from now. It suggests we're constantly tapping into new biological reserves, new regions. How did the researchers kind of conceptualize this growing pool?
They called it the candidate species pool. Think of it as the untapped biological bench warmers, if you like. Every native species globally that has the potential to be introduced somewhere else, establish, and maybe cause issues. Their simulation model showed quite clearly that this candidate species pool must have dramatically increased, especially throughout the 20th century.
So what does this fundamentally change about how we understand invasion dynamics?
Yeah.
It's not just an acceleration of old routes. It sounds like it's about incorporating entirely new regions into the global network.
Exactly. Globalization isn't just importing more cars or more grain from the same places. It's incorporating entirely new regions, and therefore new species, into the global exchange network. We're effectively building new biological trade routes into formerly isolated ecosystems, and it's that increasing accessibility of new source pools that's compensating for any historical depletion of the traditionally important source pools. We seem to be opening new doors of biological exchange faster than we can really get a handle on the old ones.
Okay, let's zoom out for a second. Because this emergence rate, it varied wildly depending on the type of species, didn't it?
Hmm.
Can you give us some hard numbers from that recent 2000-2005 data that show this taxonomic variance?
Oh, the differences are profound, yeah. For mollusks and other invertebrates, the emergence rate was, well, staggering. Literally every second first record was a brand new species, a 50% AS rate. Vascular plants and crustaceans were also highly emergent. Around 1 in 3 new records was an emerging species.
Wow, 50% for mollusks and invertebrates.
Yeah, but birds were the clear exception. In that same recent period, only about 1 in 16 first records for birds was an emerging species, much, much lower.
Okay, why are birds behaving so differently? Are they just, I don't know, better studied? Or is there something fundamentally different about bird invasions?
It seems to be a case of what they call secondary spread domination. The distinct decline in the EAS proportion for birds suggests their current invasions are dominated by the spread of species already established elsewhere. So the known villains, like the house sparrow, spreading from place to place rather than new ones arriving from their native range for the first time. The trade in birds has historically been focused on a more predictable, maybe smaller set of species, for pets or acclimatization societies back in the day.
Okay, so the pool was tapped earlier, perhaps.
Possibly, yes. However, the study issues a really stark warning here. This relative stability for birds might be tenuous. We are already seeing signs that previously untapped species, like certain neotropical birds, are becoming more attractive in Asian markets, for instance, which means the currently somewhat depleted bird pool could soon be refilled by entirely new emerging species. The dynamic could shift again.
That is genuinely sobering, especially when you consider the potential scale of future problems. Did the researchers try to quantify just how vast this global candidate species pool might actually be?
They did, and the numbers are, well, they're truly staggering. Based on their models, they estimate that the full candidate species pool represents somewhere between 1%, that's for mollusks, and a jaw-dropping 16%. 16% of the total number of species on Earth for the mammal group.
16%. 16% of all mammal species on the planet potentially waiting in the wings to become an emerging alien species somewhere. That means the reservoir isn't just large. For many groups, we have barely scratched the surface of potential invaders.
Exactly. The well is very, very far from dry. We are nowhere near saturation.
Right. So where are these emerging species first popping up geographically? Are the traditional global hubs, Europe, North America, still the primary points of entry? Or is that changing too?
Well, hotspots for emerging alien species were identified in those usual major economies: Europe, North America, East Asia. These regions obviously have massive trade volume, lots of entry points. But critically, they also saw high emergence rates in fast-growing economies like Brazil and Argentina, and significantly on many islands, particularly for invertebrates. So these regions seem to be acting as critical global gateways for new primary introductions, which likely reflects that new accessibility of source spells we were just talking about.
Okay, let's pivot briefly then to the known drivers. Even if they couldn't explain the overall high rate of emergence, the researchers used advanced statistical tools, GAMs, I think, to confirm which factors were still significantly driving the rise of first records in general. What were the confirmed drivers there?
Yeah, they confirmed the usual suspects remain highly influential. The value of imported commodities, basically how much stuff is flowing into a region, that was a robust and frequent predictor for almost every group studied. plants, insects, mollusks. It matters.
Makes sense. More trade, more opportunity.
Exactly. And land use change was also highly significant. Increases in urban areas, pasture land, cropland, they all predicted higher establishment rates for alien species. This reinforces the concept that environmental disturbance or degradation kind of opens the door, increases the chance that an alien species can successfully take hold if it arrives.
Any specific pathways highlighted?
Well, for vascular plants specifically, the number of botanical gardens in a region was a significant predictor of emerging alien species, which confirms their known, historical, and sometimes ongoing, albeit often accidental role as introduction vectors.
Interesting. Now, given how often it dominates environmental conversations today, what did they find about climate change in this specific historical analysis going back 500 years?
Yeah, it's a good question. Variation in climatic conditions, which they measured by looking at local temperature and relative humidity in the recipient regions, was actually found to be less important in this particular analysis. Now, the study focused on historical introductions over a very long period. It suggests that compared to the massive signal from trade and land use change over those centuries, climate variation wasn't the dominant variable driving the timing of these specific first records across that 500-year span. Doesn't mean it won't be crucial going forward, of course.
Right. Context is key. Now, let's acknowledge the caveats because science is never perfect. What limitations did the researchers themselves identify in their models? They weren't perfect predictors, right?
Correct. The models weren't perfect in predicting the exact time series of first records. Some models, especially for groups like fishes and insects, had pretty low overall predictive power, even when they included those confirmed drivers like trade. So that signals that essential variables are still missing from the picture.
Like what kind of variables?
Well, the researchers acknowledged that detailed historical data on specific pathways, like, say, very organized introductions by early acclimatization societies, or tracking the movements of specific plant hunters back in the 1700s, that kind of granular data is largely unavailable across the full 500-year timescale for the whole globe. And critically, their models also couldn't fully incorporate the actual measured increase in the candidate species pool itself over time. They could only infer that it must have happened to explain the patterns they saw.
Understood. So pulling this all together, this paper isn't just an academic warning. It feels like a policy mandate. What does this research ultimately mean for biosecurity teams, for policymakers around the world who are actively trying to protect their ecosystems right now?
I think the absolute key takeaway is that global invasion dynamics are still primarily driven by primary introductions, the continuous emergence of entirely new species hitting the global stage. This is not a problem that's saturating or slowing down, and that means we probably have to stop spending quite so much of our budget just checking the IDs of the known villains against historical warning lists.
You have to shift our focus, look for the unknowns.
Exactly. Because so many emerging alien species lack any invasion history, they pose a particular and really acute challenge. Biosecurity interventions must pivot, at least partially, away from total reliance on prior records, and instead invest much more heavily in, say, early surveillance and better risk assessments that focus on identifying potential door knocker species. Those species not yet recorded as alien anywhere but flagged as high risk based on their native characteristics, their potential match with new environments, and the pathways they might travel on.
Yeah, and this research strongly suggests that if we just maintain the status quo, relying on past history, these emerging alien species will just continue to slip through controls, precisely because their identities and potential impacts are so difficult to predict without that prior knowledge. We're essentially chasing a constantly moving and expanding target.
That's a very good way to put it.
So, for you, the learner, here is a final provocative thought to take away, built directly on this research. We've heard that the pool of potential alien species is vast, estimated to include up to 16% of all species on Earth, for some groups like mammals. So how quickly might that emergence rate accelerate if, or perhaps when, climate change does become a dominant driver in the future? If it starts opening up vast new regions climatically or facilitating entirely new pathways, incorporating even more of that huge, currently untapped species reservoir into the global exchange, something to mull over as we continue to redefine what native even means in our rapidly changing world.